This is lesson 96. We skipped some more, but we're still working on quadratic functions. And this deals with how to look at a quadratic equation and graph it properly. Graphing quadratic equations is pretty important these days because that's what they're talking about when they talk about the coronavirus peaking or flattening the curve. The curve's a parabola, and it's described by quadratic equations. And to draw those graphs that they use on the news and TV and so forth, they're taking advantage of lesson 96. So, here we go. Graphing quadratic functions. To be able to graph quadratic functions, you're given a graph, or you're given a function, in this case y equals x squared plus 4x plus 5. And the task is, how do you graph that? And yes, you could use a solution set, sign of the cross, x, y, substitute values in. But as these things get more complicated, that just is not a good way to do it. And it's not a very accurate way of doing it either. This way gives you all the good information you're going to need to be able to describe what's going on with this parabola you're about to graph. So the first step is you must find the axis of symmetry. And that goes back to our previous lesson where we take advantage of this formula x, the value of x, a vertical line, the axis of symmetry, is equal to the opposite of b over 2a. So we look at our given quadratic equation and see that b in this case is 4 and a in this case is 1. And we'll substitute in 4 for b and 1 for a into this equation so that we can get the axis of symmetry. In this case, minus 4 over 2. In other words, the axis of symmetry here is x is equal to minus 2. That's the first step. All right. This gives us a dotted line that is vertical, and our parabola is going to be exactly cut in half by that line. All right. Next, we find the vertex point, all right? And that goes back to our very first video lesson about the vertex being the maximum or the minimum. That becomes a very important point on the graph. So to find the vertex point, we are going to substitute the axis of symmetry value for x into the original equation. We found that the axis of symmetry is x equals minus 2. And so that gives us a value for x, and if we find what y is when x equals minus 2, we'll have a point that tells us the vertex. And so when we do that, we take x equals minus 2 and substitute in wherever there's an x. And so y equals minus 2 squared plus 4 times minus 2 plus 5. So doing the equation 4 plus minus 8 plus 5, we see that y equals 1. So the vertex of this parabola is minus 2, 1. X at minus 2, y equals 1. The vertex point. All right. We already know it's going to open, what, up or down? Yeah, you're right, up, because a is positive, right? So we know how to draw the thing. Right, now, step 3. We need to find the y-intercept, and it turns out that's the easiest part of this whole thing, because the y-intercept is the value of c, the constant, because that's when x is 0, right? Both the x terms go away. And so in this case, c equals 5, so that is the value of the y-intercept of this parabola. So now we've got the vertex line, we've got the minimum point, all right, and now we have a place where that parabola is going to cross the y-axis. So we need one other point, a point that is going to be opposite or a mirror image of the one we have for the y-intercept. It'll be exactly the same number of units away from the axis of symmetry, right? And so that puts it all together by saying, we get this thing here. We have the axis of symmetry, x equals minus 2, We draw a dotted line there. All right. We found the vertex point, minus 2, 1, right there. Minus 2 on the x, 1 on the y. We found the y-intercept, where it's going to cross at 5 here. All right. And we see that from the axis of symmetry, this intercept point is 1, 2 units away from the axis of symmetry. So its mirror image point will be 2 units away in the other direction from the axis of symmetry, right here. And that gives us 3 points that we can use to draw the graph of this parabola. And so following those steps, and certainly you might want to stop, pause, rewind, whatever it takes, go through this, and that allows you then to draw or graph any quadratic equation. All right.